This is day 2 of solving rational equations. And so the very first thing I'm going to do is I'm going to recognize that this can be factored. So this is the same as x squared plus 0x minus 1. And I'm going to come off to the side. And in order to factor this, I'm going to take the front times the back. So a times c is -1 and the inside is 0. I'm going to identify what two numbers multiply to equal -1 and combine to give us 0. So 1 and -1. They multiply to give us -1. They combine to give us 0. Because the leading coefficient is 1, I get to do x plus 1 and x minus 1. That means that this is just simply rewritten as x plus 1 and x minus 1. The second step is to identify what can x not be. So we would be in trouble if x equaled -1. And the reason is -1 plus 1 would be 0. We can never have 0 on the bottom of a fraction. Now, algebraically, we're going to take this, set it equal to 0, and solve, and that's how I'm able to show x cannot equal -1. I'll do the next one, x minus 1 equals 0. X also cannot equal +1. X cannot equal -1, and x cannot equal +1. So when I'm all done with this example, I need to first go back and make sure that it does not equal 1 or -1. I don't have to do it for the third term because I've already tried x plus 1 and x minus 1. That's step number 1. Step number 2 is we are going to identify how to get this common denominator using the LCM method. So when I look up here, I see a group of x plus 1, so I'm going to write that down. And I see a group of x minus 1. Okay, so this one has x plus 1, this one has x minus 1, and this one has them both. So when I try to find that least common multiple, I come back to this first one, I go, okay, it has x plus 1, what is it missing? It's missing x minus 1. And let me put this in a different color so it stands out. It's missing x minus 1. Now this first group in the denominator has x plus 1 and it has x minus 1. Great. This second group only focus on the bottom, the denominator. It has x minus 1, but it's missing x plus 1. The last group has x plus 1 and x minus 1. Now, every one of the three groups that we see has the quantity x plus 1 and x minus 1. A common question I get is, does it matter if x minus 1 goes first or x plus 1 goes first? It doesn't matter. As long as it has these exact same groups, we're in service. Okay, now the next thing we're going to do is once the denominators are all the same, we are going to eliminate the denominators of this rational equation. And I'm going to slowly write down what's in the numerator. So 2 times x minus 1 subtract 1 times x plus 1 equals -2. I'm going to distribute the 2 to get 2x minus 2. And then here's where a lot of students made mistakes. They distributed a 1, but they have to distribute not just a 1, but a -1. So -1 times x and -1 times 1. Let's combine like terms. 2x subtract 1x is 1x. And -2 and -1 is a -3. To solve for x, I'm going to start by adding 3 first. Dividing by 1, and I get x equals 1. I don't even need to grab a calculator and justify, does this answer work? I already know this answer does not work. Turn to your current shoulder partner and explain, why do we know after doing all of that work and it was correctly completed, does x... After we identify our solution algebraically, we go back and we check, does it match either of these solutions in this case? It does. X cannot be, this should have been a cannot be, x cannot be equal to 1, so I have to cross it out. It's called an extraneous solution. It means you do all the math right, but when you check, it doesn't work. So there's no other answers to check here. That means this particular equation has no solution. Example number 2. So the first thing I'm going to look at is I want to look at the denominator. So I see two denominators, but one of them is hiding. So 6x, I don't see a denominator. I don't see a bottom. When you don't see the number, put a 1. The next step is to decide what can x not be. So I'm looking at only the denominators. If the denominator does not have an x, like 2 and 1, I get to ignore it. So I don't need to worry about 2. I don't need to worry about 1. Oh, this has a variable. So I'm going to set it equal to 0, and I'm going to solve. To isolate the x, I divide by 2, and 0 divided by 2 is 0. So x cannot equal 0. So just like example 1, I'm going to do all the math, and then I got to make sure that the answer I select is not 0. Our third step is to identify the LCM so that we can have a common denominator in each of the three terms. So let's look here. So I see a 1 and a 2. I could write down, and you don't have to do this, but I could write down all the multiples of 1. 1, 2, 3, 4, right? The list could just keep going. And then I write down the multiples of 2, 2, 4, 6, and the list could just keep going. What is the smallest number in both of those lists? You're welcome to do that in your head, by the way. What's the smallest number in both of these lists? It is 2. So my LCM has to have a 2. And it also has to have an x. This is what I want in the denominator of all three terms. So let's look at the first term. I'm only looking at the denominator. Does it have a 2? Yes. Does it have an x? I don't have to do anything. Now I need to change this. Let's come over here because this is a little more work. Let's go over to this one. I have a 2, but it's missing an x. So whatever I attach to the bottom, I must also attach to the top. All right, next up, I have a 1. Now, in order to change it to a 2, I can't add. I can't go like a plus 1. I can only multiply or divide. So how do I get 1 to a 2 by multiplying? I'm going to go times 2 times 2. Okay, great. I've got the 2, but I need to also attach an x. And each one of the denominators, I have 2x, 2x, and 2x. Once the denominators are the same in a rational equation, we can cancel out the denominators and we can just write down the numerator. 3 equals, okay, this is tricky, 6 times 2 is 12, and there's 2x's, so x squared. I'm going to move the 3 to the other side by subtracting. There's nothing left on the left-hand side. This looks pretty complicated. I can solve this by factoring maybe, and I can always solve it by using the quadratic formula. Now, myself here, I'm like, this looks a little complicated. I know that 12, 9, and 3 are all divisible by 3, so I'm going to divide by 3. And I have 3 times 4 is 12, 3 times positive 3 is positive 9, and 3 times negative 1 is a negative 3. Now you have a choice right now to solve this part, either using the quadratic formula, or you're going to use, if not the quadratic formula, you'll use factoring. Remember, factoring doesn't always work, but when it works, it's generally the easiest. I'm going to demonstrate both ways. 4 times negative 1 is negative 4. Okay, what multiplies to give you a negative 4 and combines to give you a positive 3? That'd be 4 and 1, but they have to be different signs. The larger number is positive, the smaller number is negative. That multiplies to negative 4 and combines to 3. Most of you prefer to use this AC plus B method, so it looks like this. And I take the two values that I was able to identify to factor and go plus 4x and minus 1x. This is a factoring method. I can factor out a 4x, and then I take whatever I have from that first part and rewrite it. And I identified that magical number, so negative 1 times x and negative 1 times 1. Now the front and the back half both have an x plus 1, and the front part is a 4x and the back half is a negative 1. I set this equal to 0 and I solve, and I set this equal to 0 and I solve. You may be saying, like, Miss Bradley, I don't remember doing this, and I've had 2 weeks off a break, and this just seems like a complicated method. Is there another way I could do this? Sure. We could plug it into the quadratic formula. This is your A, your B, and your C. So x equals negative b, so negative 3, plus or minus 3 squared minus 4ac, all divided by 2 times a. All right, negative 3. Now I'm going to grab a calculator and do this work. I'm not going to do that in my head. So I'm going to do 3 squared. Don't include the square root. I'm going to do 3 squared minus 4 times negative 1. And inside I have an answer of 25 over 8. I know the square root of 25 is 5. Okay, so I'm going to achieve the same two answers just using a different technique. Negative 3 plus 5. Negative 3 plus 5 is 2, and 2 over 8 is equivalent to 1/4. Negative 3 minus 5 is negative 8, and negative 8 divided by 8 is equal to negative 1. So either way, whether you use the quadratic formula or whether you use a factoring, you can get the same answer as long as your math is correct. Now, neither one of these answers is equal to 0, so that's good. But there's something called extraneous solutions, and that means you do all the math right, but when you plug it back into the original equation, the left side doesn't equal the right side. Now, we're going to use a calculator in order to eliminate the extraneous solutions. Grab your calculator and go second plus 712. Grab your calculator and do second plus 712. Okay, so I'm going to plug this in. After everybody has cleared their calculator, please go to y equals. On the left side, this will be y sub 1. I have 3 divided by 2x. On the right side of this original equation, I have 6x plus 9 divided by 2. So I have the two functions down. And now I'm going to hit graph. Remember, I at this point believe that there are two solutions. This is like a test, and it eliminates the extraneous solutions that we cannot consider. So I'm looking to see where is the answer, and it looks like there's potentially two. Do you guys see where it crosses in two places? Does everybody see that? So I'm going to go second trace value, second trace and intersect, and I'm going to use, enter, enter, enter. So one answer is at -1, and that's what I have. So that means this is a justified answer. Now my other answer, I believe, is 1/4. Second trace, intersect. I'm going to bring this graph. There's, enter, enter. You have to use those arrows, enter. And here's my other answer, 0.25, which is equivalent to 1/4. So I do have two answers for this. I've justified them. I've used the calculator. Okay, now there's more than one way to do this. And so I want to show you really quick. If I went off to the side here, you don't have to write down what I'm putting down right now, but if I went off to the side and I wrote down something like this, and I said to a 7th and 8th grader, how do you solve this? I believe in 7th and 8th grade, you start to learn about cross multiplying. You go 3 times 16 is 48. 12 times x is 12x. Then you divide by 12, and you get an answer there of 12 goes in 4 times. Okay, so cross multiplying. One way we could solve this is by cross multiplying. Why? Because we have two terms separated by the equal sign. There's not like an additional third term that's on the left or right. So one way we could do it, although I'm not going to use this method right now, is we could cross multiply. Everybody understand? But before we get to that point, let's first identify what x cannot be. So I'm going to take x plus 2, set it equal to 0, and we can see x cannot be equal to -2. Then I'm going to take 2x plus 4, set it equal to 0, and 2x equals -4. Oh, x again cannot equal -2. X cannot equal -2. Okay, got it. What I believe I'm going to do, which I hope is the least amount of work, is I recognize that 2x plus 4, I can factor out a value. The value 2 can be factored out of 2 and 4. So I'm going to rewrite this. 2x over 2 times, 2 times x is 2x, and 2 times 2 is 4. Turn to your partner. What do you think would be the next step? Ready? All right, so now we're going to determine what is the LCM. That means in order to get a common denominator, so I can see they both have a group of x plus 2. What a lot of students have forgotten in the past is not just x plus 2. What other number is it? A 2 I need. I also need a 2. So this has 2 and it has x plus 2. Awesome. This has an x plus 2, but it's missing a 2. So times 2 times 2. Now the denominators are exactly the same. I cross it out and I can write at the top 2x equals 6x. Well, I think I'm going to move the 2x to the other side. So minus 2x. So there's nothing left on the left-hand side. And 6x subtract 2x is 4x. If you're trying to isolate the x, opposite of multiplying by 4 is dividing by 4. I got x equals 0. Now, how do I know if this is right? Well, the first thing I do is I make sure it's not equal to -2. Please grab your calculator and go second plus 712. We're always going to restart it here. Second plus 712. Second plus 712. I'm going to go up here and I'm going to put in parentheses. So I'm going to do like a double parenthesis here. I have 2x goes in parentheses, and so does 2x plus 4. Make sure to include those parentheses. You're hugging the numerator and the denominator. Then in y sub 2 on the right side of the equal sign, I have 3x and I'm dividing it by x plus 2. Now hit graph, and we want to know, do they cross at 0? Do the two functions cross at 0? there's the blue function, L sub 1. Here's the red function, L sub 2. And I can see they cross right here, which appears to be at 0. Let's make sure that's the case. So second trace intersect, I press enter 3 times. Here's the answer. The X answer is 0. This is the correct answer. All right, this is our last example in this video. Let's see if we can factor this. So I'm going to come off to the side. 2 times negative 5 is negative 10. I want to know two numbers that exist that I can multiply to get negative 10, but they combine to give you a negative 9. So I'm like thinking right now, right? 2 and 5. Okay, 2 times 5 is 10, but that doesn't give you 9. What about 1 and 10? 1 and 10 could give you a negative 10 if they're different signs, and the larger number has to be negative. So if these multiply to give you negative 10, they combine to give you negative 9. So that helps me, but this leading coefficient is different than 1, so it's a little bit more work. Within your groups, I'm watching right now, within your groups, I want you to go ahead and I want you to factor by grouping this. Okay, so I'm going to take a 2 and an X out of these first two. This is factoring by grouping. What am I left with? 2 times 1 is 2, but I need one more X to get X squared. 2 times negative 5 is negative 10, and I have the X. So 1X minus 5. What times 1X gives us a positive 1X, a plus 1? So there's 1X, and 1 times negative 5 is negative 5. Okay, they both have a 1X minus 5. Nobody's there? Okay. In front of the first part is a 2X. In front of the second part is a 1X. Give me 1 second. Can you go left using the 17 feet? Thank you so much, Rebecca. Okay, but does everybody see here how these are the exact same thing? Does everybody see that? I'm giving you a helpful hint at this level in your math. These are often the case. Okay, so the next thing we're going to do is we're going to decide what can X not be. With the help of your partner, you have right now 30 seconds to decide. If you're confused how to determine those, take this group of X minus 5 and set it equal to 0. So I'm adding 5, so X cannot be equal 5. And then I have this group 2X plus 1, so I subtract 1. I divide by 2, and so X cannot equal negative 1/2. Those are the two parts it cannot equal. Now, why do I not have to do it for these two groups? Because I already tested that. I already tested X minus 5, and I already tested 2X plus 1. Okay, so I've determined that. Within your groups, decide right now, what should the... All right, we want it to be the groups X minus 5 and 2X plus 1. This is what we want both to be. So I'm looking at only the denominator. It has an X minus 5, but it's missing a 2X plus 1. So I'm going to come over here, and I'm going to attach a 2X plus 1. Attach a 2X plus 1, both to the top and to the bottom. Now the second group is easier because it already has both. I don't need to worry about it. The third term has a 2X plus 1, but it's missing an X minus 5. So I need to put parentheses around what's already there, and now I'm going to attach an X minus 5. Make sure parentheses are already there. Okay, all of the bottoms now have these two groups. So let's eliminate the bottom, and this is going to take us another 2 or 3 minutes, and we're going to go through this slowly. So I'm going to write neat. It's not my natural. It's not naturally for me to be neat. So let me slow it down. We have 2 times 2X plus 1. Subtract 2 equals negative 1X plus 1 times X minus 5. This is what I'm going to try to solve. Let's first distribute the 2. I end up with 4X plus 2 minus 2 equals, now here's where we're going to FOIL. Front, outside, inside, last. We're going to FOIL. So front. When I multiply this, negative 1 times 1 is negative 1, and I have 2 X's. X squared. O is for the outside. Negative 1 times negative 5 is a positive 5, and there's an X. Inside, positive 1 times X is positive 1X. And last, 1 times negative 5 is negative 5. There's no right and wrong to which side you move everything, but I think we always want the X squared to be positive. Right now, the X squared is on this side, so naturally we're used to moving everything to the X squared side, but I don't like to work with a negative X squared. I like the leading coefficient to be positive. I'm going to move everything over here. So as I move it, it changes signs. This was negative. When it comes over, it's positive. I know 5x plus 1x is a positive 6x. But when I take a positive 6x and I move it to the other side, again, I have to do the opposite operation. So I'm going to subtract 6x from both sides. And a negative 5x in the same way, we're going to add 5x to the other side. All right, so over here, what can I combine? I have a 1x squared. 4 and minus 6 is a minus 2. And now I have these three to add. So a positive 2 and a minus 2. A positive 2 and a minus 2 gives us 0. And 0 plus 5 is 5. Ooh, that looks pretty ugly. That looks pretty ugly. Okay, I would like you to go ahead and I'd like you to solve this. I'm going to tell you right now, you can't factor this. So please use the quadratic formula. Again, I'm watching groups to see how well you're working with the people you are with to determine our future seating chart. Go ahead.
The information for public.
Make sure that negative 2 as we figure out the discriminant or the value underneath the radical is put in parentheses or you will get the wrong answer. So we have a negative 16, a negative 16. Now we've learned about this. Can we take the square root of a negative, anybody? We can't. So if anybody remembers from way back in like October and November, the negative sign comes outside as an I, and now the square root of 16 is 4. But hold on here. Anytime you have an answer with an I, it means it's imaginary. It doesn't show up on our graph. So this is no real solution, because the only solutions I have would be imaginary. There's no real. Include the word real. Including the word real means that we are going to eliminate any of the I answers.